let's see. Hi, Jira. How are you?
Good afternoon, Professor. I'm good. How are you?
No problem. Any question so far?
No, no specific questions. I was just here to join the lecture and try a different way of learning rather than doing the recorded lectures.
Okay. This session actually we set up mainly for question and answer. Okay.
Another reason why I joined because I remember you made an announcement last week saying that there's not a lot of show up of students, and this was
Yeah,
a good.
so far very little student join. And that means that not a lot of student ask questions. Yes. So I usually encourage student to join more sessions. Yes.
Yes, absolutely. I just wanted to take a moment and say thank you for all the work you do. So far, the lectures have been really helpful, and if I have any questions, I'll always feel free to reach out to you.
Okay. No problem.
Am I free
And
to stay, or is it better if I leave and watch the recording? Because I will have to refer back to it anyways.
no problem. We'll go through, if no people ask question, I'll go through the lecture shortly to keep student how to study. That's a short time, maybe 10, 15 minutes. That's that we will stop if no question. So don't worry, you can stay. Okay.
Perfect. Sounds good. Thank you so much.
We have 3 more minutes to go. Okay. Last year, actually, I teach maybe 1 hour, 2 hour every lecture because a lot of students have many questions. But this year, I don't know why, but nobody showed. Last year, usually they are 7, 8 students would join, but this year's almost none.
I think I'm not sure whether it is this is the reason, but typically all of our classes for Lewis are like the 6 to 9 p.m. and that's like the standard. So I think like a lot of people even work and stuff like according to that time.
Yeah, but we are using the same time. You know what I'm saying?
Mm-hmm.
We are using the lunch time of the central time. So suppose if student has question will join, lunchtime will not bother too much, right? You have question is so usually lunchtime is okay. And we said that we use the lunchtime for many years already, but this year I don't know why, but it's fewest attendance so far. Yeah, but don't worry, I actually know that you joined once. Okay.
Right.
I usually use a bonus point to curb the students. Okay, so
Mm-hmm.
uh, that I will actually look at the end of the chapter. But our purpose is not to downgrade student, but our purpose is making sure everybody who work hard get the point that they deserve. Okay, that's actually the purpose. That's why we would do curbing.
Right. That makes sense. Thank you.
Okay, 1 more minute. Hello.
Hello,
Yeah,
how are
how are
you?
you? How are you today?
And good?
Any question today?
No.
No? Okay. We have 1 more minute to go. Okay, I'll start on 10 o'clock. On my time, 10 o'clock. Pacific time, 10 o'clock. Your central time is noon time. Okay. Okay, now it's noon time already. We will get started. Okay. So this lecture 4 is on imperative programming. Okay, it start to talk about the programming paradigm. So we'll cover the imperative programming, object-oriented programming, and functional programming, 3 programming paradigm. But there are more. Okay, they are logic programming. They are the so-called list programming, okay, many other programming paradigm. And even now we have the neural network programming paradigm, okay, many programming paradigms. So today we are talking about the basic imperative programming paradigm. So first thing is that you need to know about what is programming paradigm, okay? What is programming paradigm? So we program based on the programming paradigm. That's the way that we think, okay? So if we use an imperative programming paradigm, the thinking is the same, similar. Even the language is different, its thinking is almost the same, okay? So imperative, there are several kinds of the programming paradigms, many of them. So nowadays, I would think that I would say that functional programming is very important. Object-oriented programming is very important. Parallel programming is concurrent programming is very important. Procedural programming is very important. This imperative programming is all important. So these are something you need to learn. Okay, this programming language is trying to cover these different programming paradigm. We choose Python because Python suppose the following thing: procedural programming paradigm, imperative programming, object-oriented programming, functional programming. Okay, and if you do Python on CUDA, that would be parallel processing approach as well. So basically, Python is a very versatile language. It covers different programming paradigms. Okay, so here talking about the interpreter and different kind of the programming paradigms and the languages. Okay, so procedural programming is one under structural programming. Structural programming is under imperative programming. Okay, and imperative programming is related to Von-Neumann machine. Okay, so what is a Von-Neumann machine then? Any of you know what is Von-Neumann machine? Von-Neumann machine model. We talk about imperative programming. Hello?
I can't quite remember.
Okay, this is something you need to know, okay? So Von-Neumann machine is a machine with memory. That's it. Very simple. John Von-Neumann architecture. Okay, so this one, Von-Neumann architecture is the one that you usually see this kind of computer in the Computer 101 book. A computer with a central programming unit and the control logic and the memory unit. This is called Von-Neumann machine. So nowadays we have the neural network. Does the neural network following this Von-Neumann machine? Yes or no? Neural network, deep learning. Do they follow this the so-called Von-Neumann machine or no?
I think so because they act like storage in memory. So
No, the answer is no.
oh, okay.
That's why you have neural processing engine. That's a separate piece of the hardware. Okay, that's a separate piece of the hardware. They do calculation totally differently. Okay, they do calculation totally differently. They are mapped onto the GPU, but the computing structure is different from the normal Von-Neumann machine. They are using this kind of networking, hidden layer networking. Okay, so your programming paradigm will affect your computer architecture and affect the way that you do calculation. Okay, and well, imperative programming is the procedural programming. So everybody know what it is. Okay, so then you also need to know what is object-oriented programming. It uses object methods, and it is also imperative programming, but it's not procedural. Sometimes it's not procedural. Okay, you do need to learn about what is OOP principle. So that's actually coming in the coming lectures. Okay. So that, and then there's also event-driven programming. Okay, how events on the cell phone got handled. Okay, so that's event-driven, and then it's multi-threaded in your language as well, maybe Java. Okay. Okay, so here we actually talk about what is imperative programming and also what is declarative programming. Okay, declarative programming means not imperative. Imperative programming means that command after command, statement 1, statement 2, statement 3, and then jump to another statement, something like that. Okay, those if then else and the loop, that's imperative programming. Declarative programming may be just functional programming, maybe logic programming, maybe list programming. Okay, it will not be using the statement after statement. Okay, so we talk about what is sequential programming. Okay, that's old times programming, and there's evaluation of the expression. Okay, how expression got evaluated, and then control flow of the program. So these actually we don't spend too much time. We just go through. You can read it. Okay. So my purpose is just that you know these are topic in the imperative programming. Okay. So next one is structured programming. So sequential programming just have jump to, go to. Okay. There is no structure, no for loop, no if then else. So structured programming will have if then else, while loop, for loop, those kind of program structures. So then next one is a structured programming. So C language already introduced the structured programming. Okay. So in Fortran and the basic language, in the early 1960s, those language are mainly sequential programming. So they had a lot of go-to statement. Okay. And then in 70s, we start to have C language that's already structured programming. Okay, and then there are a lot of program structures you need to know. Okay, and then recently we have an iterator. Okay, object-oriented programming. We have iterators. So iterator is a new concept. Here you introduce some iterators. Okay, and we don't go over it. So these are generator, iterator, and iterable. Okay. Okay, you should study it. I don't have time to cover. The next one is the function. Okay, and imperative programming has a function, so it has a definition of what is function and how function being called, and then different idea and exception. Okay, next one, exception. So another thing we follow, and why we need to have the tail recursion to optimize your recursive call. Okay. So why we need to have the tail recursion? Anybody know? Why tail recursive function is better than non-tail recursive one? It's because tail recursion will be optimized by compiler, so it would be faster. Okay. Okay. Anyway, these are the tail recursion, and then next one is stack layout. Okay, then it talk about the memory for the local variables. So it's the memory model for C language and Python language. Okay, so and then there's a calling sequence. So there's a prologue and the epilogue. Prologue is the procedure that you go into a function. Epilogue is the procedure that you get out of the function to finish up. Okay, you need to know about these two things. Okay, other than that, it's actually prologue, and we're talking about the calling sequence. Okay, you can look at the code. That's it. Okay, that's it for this chapter. Any question? So the whole chapter we just go through once about what is in here. Yeah, question?
I was gonna say I don't have questions, so.
Oh, okay.
From my side.
Yeah, basically we had the videos for the detail. You can watch the video. Okay, we had a recorded video. So my purpose here is just go through the chapter, making sure you know what is going on in this chapter. Okay, that's the main purpose. Otherwise, we actually will answer question That's the main things that I would like to see. So if you do have a question, come back. Okay, we can discuss. Okay. Okay. If no question, that's it for today. Okay. See you next time. Bye bye.
All right, thank you. Bye-bye.
Bye bye.